all, I'm thrilled to be here. Thank you very much to the team at Airbyte for hosting us. It's always a privilege to be up on the digital stage talking about data to folks who love data. So thank you. My name is Paola, and I'm a co-founder and product lead at Astronomer. We are the modern data orchestration company and the commercial backers of Apache Airflow. And I love the prompt for this talk today, which is, if you could write one message to all data teams on a billboard, what would it be? And over the past 5 years, we've worked with hundreds of data teams to know that the message we have for you today is quite straightforward. Data orchestration is not just running jobs on a schedule. It's the heartbeat of a data-driven organization. And there's 3 takeaways, I think, from today. The first is orchestration is a requirement for a data-driven organization. 2, orchestration is the key ingredient for data lineage. And 3, it doesn't actually have to be that hard. So let's take the data team at an example company called BigCo. This team has a new initiative to report on data for monthly active users, let's say. And there's a team at this company that is tasked with and needs to produce a few things. Number 1, deliver a dashboard about their users to executives, much like the one you see here, but also do some in-app recommendations and also maybe build some data products that help other teams in their organization, say customer success, self-service their own data domains. And the team at BigCo, much like many of us, are looking at some basic data building blocks that they have at their disposal. At minimum, they've got a data warehouse and a data lake, an application database with user activity, and to access to third-party APIs for external tools that they already use and have user data in. And to do their job right, the output here needs to be, again, that dashboard, that data product, that predictive model. But what starts off as a clean diagram with a pretty basic question on a whiteboard quickly turns into a slurry of tools that we now know of as the modern data stack. And to actually build that dashboard and those data products, you actually need to use dbt for transformation. It turns out you use both Databricks and Snowflake for your data warehouse and data lake, respectively. You use Fivetran or Airbyte for ingestion. You use High Touch for reverse ETL. You use Great Expectations or Monte Carlo for data quality. And the best part is that all these tools have all gotten amazing in what they do. But all these arrows, the process of moving and coordinating data between these best of breed tools for your use case, this is data orchestration. And you can see at the bottom here that we've just now introduced the team and the concert of personas at BigCo that will actually do all of this. You know, at minimum, you've got a data analyst who's a master of SQL and wants to produce that dashboard of insights in Sigma and just needs a way to productionize queries that run every time that data arrives. You've got a data engineer who spends most of her time in Python and is responsible for that ingestion pipeline. But they also sometimes might need to fix a schema upstream. Then you've got a data scientist who works in pandas and notebooks to produce a prediction model, and they need to make sure that the code has enough compute, and they might need to use a data quality framework to actually detect and avoid model drift. And the magic of these teams is that you've got all these personas working together on the same stack with different expertises to produce specialized output that will deliver those set of artifacts that BigCo needs to be successful in their own industry. So again, data orchestration is not just running jobs on the schedule, it's the heartbeat of BigCo as a data-driven organization. But what's actually the glue that makes all of that orchestration possible? Well, in an open source world, Airflow has been the de facto standard as a scheduler here. At its core, Airflow is built to author, schedule, and monitor data pipelines that connect that slurry of tools that we've been talking about. And as you know, Airflow has done an excellent job of, unleashing the power of Python and giving you a place where your data movements are defined and tracked as code and can scale, cultivating a network of providers and integrations, and an interface that allows you to check the status of your tasks. And Airflow is used in hundreds of thousands of companies, and that's growing. And a lot of Airflow's popularity was due to a pretty well-defined problem. When it started, a world needed a scheduler, and Maxime, who's the creator of Airflow, summarized this very well in an announcement post that he made in 2015, where he said, as people who work with data to begin automate their processes, they inevitably write batch jobs. These jobs need to run on a schedule, typically have a set of dependencies on other data sets, and have other jobs that depend on them. So at its core, again, scheduling was what Airflow is built to do, and it's good at it. But we know that was a long time ago, at least relatively in the data world, and that in many ways, there were things in Airflow, even in its job as a scheduler, that became limits as the modern data stack began to emerge, right? It's way harder than it needs to be to install Airflow and actually test the DAG locally. The lack of any notion of data sets is pretty crazy in a system that's all about data. The lack of metadata about what tools you're actually connecting and who owns them and what the output of each pipeline is makes it hard for, let's say, an on-call data engineer to properly diagnose issues when a DAG fails. And of course, writing a DAG still requires knowing Airflow primitives like connections and variables, and they're actually not so easy to work with, even if you master Python. And so there's been plenty of chatter, as we know, on the internet about these problems, and we acknowledge that. But as the usage of Airflow grows and the community continues to invest in the open source project, a new Airflow actually starts emerging. We're now in 2022, not 2015, not 2020 when 2.0 came out. And since then, the open source community has already delivered. We've done things like a Taskflow API that requires much less code for passing data between tasks, data-driven scheduling so that you can kick off a pipeline not when it's midnight UTC or weekly, but just when that data set that it actually depends on has actually been updated. Dynamic task mapping so you can auto-generate tasks at runtime based on the conditions of your DAGs instead of hard coding them. A Python SDK that's actually maintained by our team at Astronomer, but is entirely open source. And it allows you to write an ETL or ELT DAG and automatically handles things for you, like loading a file into Snowflake, transforming that file in SQL, creating a temp table for you so you don't have to do that in Pandas. And then, of course, a quickly changing Airflow UI that is only getting better, and an open lineage standard that is growing quickly in adoption that we'll talk about in a little bit, and has been adopted by companies in the likes of Microsoft. And all these things should be incredibly exciting, I think, to data teams, whether they use Airflow or not. But Airflow is getting better at doing the job that it was meant to do, scheduling. But to per the point of this presentation, orchestration isn't just scheduling and it isn't just Airflow. There's an important layer of data ops that follows once you're running real things in production. Even if that data scientist wrote a data pipeline that helps generate that predictive model, it then becomes about documentation, standards, testing, shared libraries, CI/CD processes, compute optimization. And all of these reasons is why we all know that it's hard to get a data project actually running in production. But in order for companies like ours and companies like yours to be successful, they need to, right? And getting that to work end to end is actually about a lot more than scheduling. And so while this really is not a pitch for Astronomer, we have to acknowledge that that gap, which I think all total up to this need for orchestration universally, needs to be filled by something like Astronomer. So things like multi-tenancy and workload isolation. How do you make sure that you can run that pipeline 1,000 times on shared compute? Low-code authoring. How do you build other frameworks for those DAG authoring personas to actually participate in this ecosystem? CI/CD tooling to enforce software development best practices, things like native branch support or GitHub integrations. And then a managed compute layer that you can't discount, right? So to run all this stuff, you need servers, and who's going to manage those servers? Do you want to hire a full-time person to do that? Or do you want to not deal with it and spend your time elsewhere? And then things like an observability suite that builds on top of those open source lineage capabilities and offers even more. And so while we found that Airflow is at the heart of data orchestration platforms, teams have to extend it, usually themselves, to meet the demands of their personas, their use case, the velocity that they need to advance at. And this is precisely where Astronomer provides value to the hundreds of our customers that work with us. And I actually want to emphasize the point of lineage here. So open lineage is an open standard that defines metadata from a variety of tools like Snowflake and dbt to make sure that that metadata actually follows the same structure and can easily be read and used and analyzed. But to actually extract that metadata and turn it into a really beautiful and centralized lineage graph, it logically follows that you need a data orchestration tool that actually captures that metadata in real time, because that metadata doesn't come from when after the job runs. It comes when the job is literally running. And if you're not running your jobs in a centralized orchestration platform, you're just not going to get that value. So again, you can't really do lineage with us without a centralized scheduler. And if you use Airflow, that is extremely easy to do. And if you do this right, these things happen, right? Your head of biz ops can look up the definition of a monthly active user. Your head of customer success can create a new onboarding report that uses that metric. Your data scientist can create a new DAG that runs that report daily. Your ML engineer can build a new model that investigates the success rate of sales calls with that monthly active user metric. And your data engineer is alerted of unexpected variance with that metric. And the best part is that none of these people have to master Airflow primitives to do their jobs. Airflow and Astronomer and data orchestration is functioning silently behind the scenes. And these people are enabled to actually produce the value that they need to for their organization. So I'll finish this off with one quote, and that is, a scheduler is required, but not sufficient, just as musicians and their instruments are critical to a performance, but useless without a conductor, a score, and a concert hall. I am very much stealing this from Stephen Hillian, who is our VP of Data and ML at Astronomer, but I think it captures the spirit of what we're trying to get at here. And I hope this excites you as much as it excites us. And with that, I will close. So thank you.